Hey, how's it going? We're just gonna look at a part two, basically, of our introduction to radicals and rational exponents. Today we're going to be looking at the cubed root function here, and you'll note that the parent function I've named g, and it's g of x equals the cubed root of x, which is also equal to x to the 1/3. Now remember, we've already previously discussed how to rewrite radical into exponential form, and we'll continue with that today. We've mostly just did square root, but now I'm hoping that you build the pattern for finding the cubed root. The domain is the set of all real numbers, and the range is the set of all real numbers. But be careful about the range here. It does keep going on, but it's interesting. But it is the set of all real numbers. What I want you to pay close attention to is this. First and foremost, the blue graph that you see in front of you with 2 points labeled A and B, notice the 2 points, that, what their actual coordinates are. A is -1, and B is 1, 1, and it does pass directly through the origin. Today, what we're going to look at, basically from this function, is actually starting to look at horizontal shifts and vertical shifts when we have some kind of radical involved. And I'm hoping you'll see the basis for that momentarily. So let's get started. All right, so I've got a few things up here. First off, I can just turn that, well, I don't have to really turn it off. You can see f of x, and you can see g of x. Now, they're really the same color, and they're overlapping, okay? The idea here is to show you that in f of x, if you look up at the green in the corner, I can't point to it, but I can do this. No, that doesn't even help you. But I'll move the slider in a second. But if you look at f of x, it equals the cubed root of what? X minus a. Okay, well, what's a? Well, a is any number. Now, when I hit the play button, I want you to take a look at how the origin or the root, if you will, moves. And that's something that you really want to keep in mind. What is a root? It's when something passes through the x-axis. So let's take a look at how f behaves. Huh. What do you notice happening? Well, a lot of cool stuff. I mean, that's pretty sure. But I mean, like, really, what do you notice is happening? C is only changing on the x-axis. Now, what's C related to? C is related to the A. Now, watch. If I stop this for a second and I just pick something like -4, right? And I hit enter, it jumps right to -4. So if A is a -4, then the expression, the function f would actually look like x plus 4. It's exactly the opposite. If I go back over here and I type in, watch, ready? If I type in just 4, jumps all the way to 4. So now A is 4. So now we're looking at f as being the cubed root of x minus 4. So notice the horizontal shifts, okay? I'm gonna now put this all back to 0, so you can see the original, oops, we don't need that many zeros, back to the parent function at hand. Now, let's take a look at how a vertical shift works. And if you know, what I have down here is g. Now, g is really the one that's in blue, and you'll notice that g is the cubed root of x, and then you add b, or subtract b. Now, b is going to be a positive or negative number between 5 and -5, as indicated by the slider right here. Boop, 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 boop. So watch what happens when I hit play. Dun, dun, dun. Da-da! H just moves up and down, but the function stays the same. Oh, F is coming up. Whoa! Boom! Unity. Okay, that's awesome. And you see it. Boom. So, okay, let's stop it for a second. And again, let's look at what happens. If I put in a positive 4, do you expect it to go up or down this time? Now remember, the horizontal shift is actually opposite. If you wanted to go 4 units to the right, you'd actually be going backwards. And we'll take a look at that again at some other point, but make sure you ask your questions in the discussion. So if I hit 4 and hit enter, I automatically move up. It's positive. I am shifting that parent function up 4 units. And you can see it as, your 1, your 2, your 3, and your 4 all the way to H, from E to H. Likewise, if I type this in as -4 and hit enter, it jumps all the way down to -4. So the vertical shift is very easy to locate. So what do I want you to take from this right now? The idea here is that we can take this parent function, the cubed root of x, and we can move it, just like the square root, we can move it left and right or up or down based upon the functions that we have. So if we have something like f, let me turn off g for a second so you can just see f. If we have something like f, where it says the cubed root of x minus a, and you move it positively, you see what happens, right? It looks like you're moving to the right, but really, you think about it, you're really minusing that value from x, right? So it kind of looks like negative, and I just want you guys to be, pay close attention to that, all right? Notice that -3 would automatically change this to the cubed root of x plus 3. And that's something to keep in mind. All right, now just for fun before we go. We're looking at the sketching of the graph. Everybody be happy. All right, if there's any questions, please make sure to ask them in the stream. And thanks very much. Have a great and happy, wonderful day.